Hello everyone, so we're going to keep on going with working with multiples and factors. So we're going to get into the least common multiple today. We've already gone over greatest common factor, and it's slightly different than the GCF, so we have to make sure we are careful with not confusing the two. So we're going to go over a few methods on how to do least common multiple. First one being using our factor trees. So the idea is pretty similar. We start off by making our factor trees. We're going to write out each factor one time. So based on this tree we have on the right, we're going to go ahead and fill that out right now. So let's go ahead and do so. So I see that the first tree has 2s and 3s. And the second tree also has 2s and 3s. So that's me writing out the factor one time each. Now I'm going to look at the factor trees individually. So multiply out the greatest number of times that each factor appears when looking at separate trees. So that's what I'm going to multiply out. What's the greatest amount of 2s that I see on either tree? So the tree on the left, I see the 2 twice. And the tree on the right, I see the number 2 once. So I'm going to multiply the number 2 twice because that's the greatest amount that I see the number 2. That's the most times it repeats on an individual tree. Now I'm going to look at my 3s, and I've got the 3 once here, twice here, versus the other tree where I see it 1, 2, 3 times. So that tells me the greatest amount of 3s that I have is 3 times. So I'm going to multiply the number 3 times. So that's going to give me my LCM, or the least common multiple. So that would be 27 times 2, which would give me, so my answer would be 108 for the LCM. So once you multiply all these numbers out, you get 108. Remember, the number of times that I repeat the 2 is the most times that I appeared on the first tree. The number of 3s is the number of times I saw the 3 repeat the most on the second tree. All right, let's go ahead and move on to talk about the other methods, and we'll do some examples. So second method would be the ladder method, which works the same way as the previous method. The only difference is how we get our final answer. So you still make your ladder the same way, divide, 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 all the way around. But this time, we know the GCF is the numbers on the left side, the 2, and the 2. But for the ladder method, it make the giant L all the way across. So it's everything on the outside, including the bottom and the left. So the LCM in this case would be 2 times 2 times 2 from the left, times 2 times 5 from the bottom. So that's 2 times 2 is 4, times 2 is 8, times 2 is 16, and 16 times 5 is 80. So our LCM here is 80. All right, let's look at the last method. The last method is the list method. It's actually kind of a nice method, but it only is nice if the LCM is a small number. You might end up having to make a very large list. So it's called the list method because you just write out the multiples of the number. So what I mean by that, if I'm doing 2 and 8 as my LCM, I would just write out all the numbers that are multiples of 2, 2, 4, 6, 8, 10, 12, 14, and so on, 8, 8, 16, 24, and so on. And then you look what they have in common. So we can see that they have an 8 in common, a 16 in common, and a 24 in common. But because it's the least common multiple, so which one's in common, but we want the smallest one, my answer here would be 8. So the LCM in this case would be equal to 8, although they have 16 and 24 and many more other factors in common. All right, so again, my favorite one tends to be the ladder method. This method kind of works. I'm not a huge fan of the factor tree method because it's kind of confusing and people seem to mess it up, and then they confuse it with GCF method. So I'm going to go ahead and do these 4 examples. All 4 of them are going to be done with all 3 methods. So feel free to copy whichever one you want, copy all 3, but at least have minimum 1 of the methods. So I'm going to start off with method number 1, which would be actually I'll start with the list method, and so you can see like the difference, why it's a good method but not necessarily always the best. So I'm going to start with 8. I'm going to write out the factors, 8, 16, and that's where your multiplication chart might come in handy. And I'm just going to stop at 48 here. I'll do a few. Then I'm going to do 12, and I'm looking for where they match. So 12, 24, 36, and I already see there's a match here. So I can see that they have a common multiple of 24. So the LCM is 24. This is the list method. Again, it works nicely for the least common multiple. But again, this least common multiple can be somewhere way down the list, so it might not always be the most efficient one. So I'm going to go ahead and do another method. I'm going to do the ladder method, which is actually, again, my favorite of the three. So I'm going to do my L shape, put the 8 and the 12 in there. These are both divisible by 2. You would get 4 and 3, no, I'm sorry, and 6. Divide by 2 again, we get 2 and 3. So remember, ladder method is make anything that's on the outside multiply. So it's all of this right here. So all of these get multiplied. Whereas the GCF, it was just the ones on the left. So the LCM, it's 2 times 2 times 2 times 3, which would be 2 times 2 is 4, times 2 is 8, 8 times 3 is also 24. You get the same answer. And then there's also the tree method. I'm going to clear this out, and you can see the last method. All right, so last method is tree method, so we're going to go ahead and do our factor trees. This is 4 times 2, 2 times 2 times 2. All right, there's our first tree, 6 times 2, and 2 times 3 times 2. Remember, this one's got to be very careful. It's not what they have in common, is which tree has the most of each number, and that's what you multiply. So I have the factor of 2. So the most times the number 2 shows up in either tree is 3 times on the left. So it's going to be 2 times 2 times 2. Now my next factor is 3. The 3 only shows up on the right side, so that's the most times it shows up. So we multiply by 3. And this multiplies to 24. So that's how the tree method works. Again, which tree has the most of every number? So which tree has the most of every number? All right, let's go ahead and go to number 2. Let's go ahead and start with the list method. So I'm going to go with 60 and 72 and start making my multiples of 60. So we have 60, we have 120, we have 180, we have 240, we have, let's see what's next, 300, and so on. We'll stop there. I'm going to do my multiples of 72, 72, 144, 216, 288. And notice that I've written these numbers down and I still don't have a matching pair. So this is where the list method is probably not the best one, just because who knows how much further I need to go in order to get my LCM. So I'm going to stop this one for now and we'll come back and finish it maybe later if it makes sense. But as you can see, the list method, again, not always the most efficient, because I might be writing this list down for quite a bit before I see a matching pair. So again, nothing is matching so far. So I'm going to kind of skip this one for now and go into the next method, which is I'm going to do the ladder method, which again, ladder method is very nice for larger numbers because usually the ladder doesn't get very large. So I'm going to go ahead and say, oh, I can divide these by, let's say, 6. So 10 and, that's not going to work for 10. 10 and, let's say, 12. All right, let's go ahead and divide one more time. I can divide by 2. That's going to give me 5 and 6. All right, so I'm going to have my L shape. So here it is, everything on the outside. That's going to be what's multiplied for the answer. So my LCM is 6 times 2 times 5 times 6. So whatever that is going to be my solution. So that's going to be 6 times 2 is 12. 12 times 5 is 60. 60 times 6 is 360. So I believe if I would have gone one more on my list at the top, I would have gotten 360 next here. 288 plus 72 would have given me the 360. Actually, I was just one off here. So here's the 360 as well. All right, so we see that both answers match on the list and the ladder. Let's go ahead and see our answer in the last method, which is a tree method or factor tree method. So let's go ahead and do our trees for 60 and 72. We're going to go start breaking these down. So again, this is going to be a slightly level tree. So let's go ahead and do our tree. So here we go. We have 3 times 2 times 5 times 2. 72, we can do 12 times 6, We're going to multiply that. We'll factor that out to, let's say, 6 times 2, 2 times 3, and we have one more level to go, 3 times 2, and I'm just going to drop the rest of them. All right, so I'm going to ask myself, what's the most amount of 2s I see on either tree, the first one or the second one? The second one has 3 2s, so I'm going to use that for my GCF. The most amount of 2s is 3. Now the next number, 3, what's the most amount of 3s that appears on either tree? I see 2 3s on the right. And then I have another factor. I have the number 5, and it shows up on the left tree. There's none on the right, so I have to use 1, 5. So this is going to be what my answer comes from. So 2 times 2 is 8. I'm sorry, 2 times 2 is 4, times 2 is 8. 8 times 3 is 24. Times 3 is 72, and times 5 is 360. So the LCM is equal to 360. So again, same answer for all of them, just pick the method you like best. So let's go ahead and do the last two. So we have the number 20 and 45. We have some variables. Again, let's not worry too much about those. So let's go ahead and write these out. We have 20 and we have 45. I'm going to start writing out my factors. We have 20, 40, 60, 80, 100, 120. Let's see, that's enough. We have 45, 90, 135, 180, and it looks like I'm going to stop with this one. I'm going to continue the next one. We have 140, 160, and there it is, 180. So again, my LCM is 180. All right, let's go ahead and do the second method, which is a ladder method. I'm going to go ahead and do that. So I'm going to do my backwards division sign for my 20 and my 45. And I can divide these by 5. We get 4 and 9. And that's pretty much it there. We're going to go ahead and take our numbers. We're going to multiply. So my LCM comes from 5 times 4 is 20. 20 times 9 is 180. And we still have to do the variables. Now for the variables, for the LCM, it's the opposite of the GCF. It's not what they have in common, it's what's the most amount. Just like with the factor tree, what's the most amount that appears in either one. So in this first one, we have x6 and x5. The most amount that appears is x6. For the y is the same thing. We have y and y squared. What's the most amount of y's? Same thing for the other one, since we didn't do it earlier. Let's go ahead and write that in. What's the most amount of the variable? All right, let's go ahead and do our last one method for this one, which is the tree method. So let's go ahead and do, oops, lost the picture. There it is. Give it a second. All right, there we go. We have our tree. We're going to go with 20 and with 45. All right, let's go ahead and fix that 5. So we have 10 times 2 and 5 times 2. We have 9 times 5 and 3 times 3 times 5. All right, again, LCM is what's the most amount of each number. What's the most amount of the 2's? We have 2 2's. What's the most amount of 3's? We have 2 3's on the right. What's the most amount of 5's? We have an equal amount on each tree. We just have 1. And then we multiply that. 2 times 2 is 4, times 3 is 12. 12 times 3 is 36, and 36 times 5 is still 180. And again, what's the most amount of x's? We have 6. And the most amount of y's, we have 2. All right, let's get to our last one, where we have three numbers. So we're going to do the same thing, but with 3 lists, 3 of everything. So let's go ahead and do that. So we have the numbers 32, 80, and 120. So I'm going to write my factors of 32. So we have 32, 64, we have 90, let's see, 96, and I'm going to stop there for now since I don't have them memorized. I have to look them up. 80, 160, then we have 240, and then we have 320. And we have 400. I'll stop there. Hopefully there's a matching pair anytime soon. Let me see. We have 120, 240, 360, 480, and let's see. So just looking at this, it's looking like it might not match anytime soon. I mean, I can write probably a few more numbers on some of these and see what happens. I know I can probably go to the next one here and get 480. And I know that's going to match the second and the third one, but the first one's not looking like it's matching. So if I keep doing 32s all the way down the line, I may eventually get to 480. And I wanted to do 128. So if I do a few more and do 128, so far these are matching. I would do 160, 192, 224, and I'm not even like, I'm pretty much barely halfway there. And actually this does continue. I'm gonna write them all out, and you'll see that it's actually gonna get there. 256, 288, 320, 352, getting closer, 384, I'm kinda 100 away, 416, 448, and there it is, 480. So I will eventually get there, but it took me a long time on the first list. And if I didn't get there, I would have to keep on going. Again, that's the reason why this one might not be the best one generally. Sometimes you'll get the number right away, like in problem 1, but not necessarily always, especially when you have 3 numbers. So I'm going to go into the next method, which is the ladder. So I'm going to go 32, 80, and 120. And I can tell that these are divisible by 8. So I'm going to divide by 8. That's 4, 10, and 15. I'm going to now divide by 2, which gives me 2, 5, and 3. Now, for the LCM, you're allowed to do the following, which is continue one step further. There's nothing that divides, that's not 3, I'm sorry, 15. Hold on, did I make a mistake? 4, 10, 15. Yeah, I divided by 2, so let me go back. Actually, I made a mistake when I was explaining this. All right, so once you divide by 8, you get 4, 10, and 15. You divide by 2. But notice that you can only divide the first one and the second one by 2. So you are allowed to do that. For the LCM, it doesn't have to divide into all 3 of them. It's fine if it just divides into 2 of them. So that's because you want the least common multiple. You're not looking for a common factor. So let's go ahead and divide by 2. Sorry about that. I just confused myself. 5 and the 15 would stay 15. So this is the one you got to be careful of. We did not divide this one. We just divided the first one and the second one. So that's allowed. And now we can go ahead and divide one more time. But this time we're going to divide the second and the third one. So we're going to go ahead and divide by 5. So we get 2, 1, and 3. All right, so now these right here will be my LCM. If you go ahead and multiply, 8 times 2 is 16. 16 times 5 is 80. And 80 times 2 is 160. And then you multiply it by 3, you get 480 as well. So we get the same answer for the LCM. Let's go ahead and do the last method, which is a tree method. So we have to make the tree for all 3 of the pictures of the numbers. Here's our first tree. Let's go ahead and do the next one. We can do 16 times 5. We have 4 times 4 times 5. And we can break that to 2 times 2, 2 times 2, and 5. So, and then we have one more to go, 120 times 10, sorry, 12 times 10. We'll do 6 times 2, 3 times 2 times 2, and the 10 can be 2 times 5. All right, so remember GCF, the LCM, least common multiple is the most amount of each kind. So we have the 2 5 times, 4 times, and 3 times. So my LCM would be the 2 5 times. There's no 3, oh, there is a 3, so we use that one time. We have 5s, we only have 1 5, so we use a 5 once. And if we go ahead and multiply this, we will also get 180. So after you do your work, pick which of the three methods you want, do it that way, and good luck.